On the screen we have a pump performance curve and there's a minimum continuous flow line. Can you elaborate on what this means?
This is his recommendation for minimum flow in that pump, bearing in mind that the further you move to the left of best efficiency point, your impeller is going to start to come under various recirculation loads. Okay? So what he's saying is here, the unsatisfactory operation is limited to this band of flows moving. So anything to the right is okay, anything to the left is not okay. That's a basic approach to minimum flow conditions. But what you get after that minimum flow conditions is excessive vibration, and that will transfer along the shaft. It could damage your seal, it could damage your bearings. So you really don't want to be operating in that zone. And you certainly don't want to be operating right back here, because you should never be running pumps at closed valve head, or even close. Even as soon as you get to that sort of zone, much closer here, plus or minus 10%, or plus 10% on zero flow, you're going to get overheating, because you've got churning occurring inside of the fluid inside the pump. I personally wouldn't operate a pump in this zone. I would be looking for installing a bypass valve so that you can bleed part of the flow off into another circuit and you still get adequate cooling effect from the operation of the pump.
On the screen we have a pump performance curve. We usually get asked what is the minimum flow for this pump, right? What we tell our customers is basically you can't wind the speed of the motor less than 20 hertz, so 580 RPM for a 4-pole motor. Right. So the minimum flow is 49 litres a second, and if I represent that on a variable speed curve showing both of them together, this is how it looks. Can you elaborate on the minimum flow point we've given?
Yeah. When we talked about minimum flow earlier, we were talking about minimum flow of the pump at a fixed speed. Okay. And what happens to the mechanical operation of the pump when you go closer to closed valve. What you're talking about now is a different scenario. You're talking about a situation where you're going to slow the pump down. Now, in that situation, there is no minimum speed for the pump. It's not the pump that's the limiting factor. The limiting factor is the drive. And if you're on a variable frequency drive, what you're doing is actually taking a sinusoidal waveform into the drive and you're chopping it up into bits and you're changing the frequency and you're going to produce a much lower speed. Okay? So you've then got to ask yourself, what is the effect of running at these lower frequencies on the drive itself? It doesn't affect the pump at all.
On the screen we have 50 hertz operation and 20 hertz operation. Why do you think the customer's asking for a minimum flow duty point?
My assumption would be that's an operating point that they want to have in this for their system, for a low load condition, for example. And it's something I would expect them to show you on a load profile. How often do they actually operate at this point compared with that point? It could be that this is the normal operating zone when it's the middle of summer or something like that. There's a very heavy heat load to handle, so they want a high flow. With that high flow, they will get a much higher system resistance. If they drop the flow back down because they haven't got such a heat load to manage, then you can operate at this point. And that's straightforward application of the affinity laws. So that's the effect of speed on flow and head. However, when you're talking about minimum flow conditions, it's not so much about the pump, it's more about the drive. Because the drive won't like to operate at low frequencies. They're not designed to operate. Most people that I've come across talk about 25 cycles. And at that situation, they can manage the different electrical loads that come onto the windings of the motor. Remember, you're not getting a sinusoidal waveform on the motor windings anymore. You're getting a drive waveform onto the windings, and that can create vibration. It can create damage to the insulation. There are a number of electrical features that the motor manufacturer won't like because you're operating at that lower frequency. So it's not really a pump issue, it's more of a drive issue, in my opinion.